Okay, today we're going to talk about using the quadratic formula. And you might be thinking, well, when do you use the quadratic formula? Well, anytime you are working with a quadratic function, you can use the quadratic formula. So you might be thinking, well, what's a quadratic function look like? Well, let me show you. It could look like this, or even this. So anytime you're dealing with a quadratic function, you're going to see a parabola when it's graphed. So how does the quadratic formula play into that? Well, the quadratic formula helps us find the zeros, the roots, or the x-intercepts. All three of these terms really mean the same thing as it pertains to the quadratic functions and the quadratic formula. So what we're looking for is, if we were to graph that quadratic function, where would it cross the x-axis? Or what does that value have to be when y equals 0? So I'm going to show you the quadratic formula, which will help us to find that answer. So this is the quadratic formula. And you might be looking at this formula and thinking, wow, that is a very long, complex formula. But it is a formula that will work every time for any quadratic function. So what we're going to do today is we are actually going to walk through several examples on how to find your zeros, your roots, or your x-intercepts using this quadratic formula. So here is our first example. The very first thing that we have to do is we have to identify our a, b, and c values. So I'm going to start here with a. So a is going to be the number that is in front of our x squared, and in this case, a is going to equal 1. Our b value is going to be the value that's in front of the x, or the coefficient to the x. In this case, our b is going to equal negative 10. And then finally, our c value is going to be our constant, or our value that does not have a variable. And so our c equals 9. So now I'm going to simply substitute in the a, b, and c values from that particular equation into the quadratic formula. So I'm going to say x equals negative b. Well, my b is negative 10, so I'm going to have negative 10 plus or minus the square root b squared, so negative 10 squared, minus 4 times my a value, which is 1, times my c value, which is 9, and that whole problem divided by 2 times a, which is 1. So let me go through and highlight this now so you can see where I substituted in the a, the b, and the c. So there are my a values. You can see that I had 2 a's in my quadratic formula, and you can see where I substituted those in. Here's where I substituted in the b values, and then finally my c values. Okay, so now that we have everything substituted in, let's simplify this. Okay, so we have x equals negative 10 is going to become positive 10, because a negative times a negative is positive. I have plus or minus the square root. Well, let's see, negative 10 squared is going to be 100, and then minus 4 times 1 times 9. Well, that will give me 36, divided by 2 times 1, which is 2. Over here, I'm going to simplify this a little bit more. So I'm going to have 10 plus or minus the square root. 100 minus 36 is going to be 64, divided by 2. That means that x equals 10 plus or minus, well, the square root of 64 is going to be 8, divided by 2. Now this is where it's going to break into two different answers. So I'm going to have x equals 10 minus 8 divided by 2, and x equals 10 plus 8 divided by 2. That plus or minus in that equation, at the very end, we have to break that into two different problems. So let's see, 10 minus 8 is 2 divided by 2, so x equals 1. 10 plus 8 is 18. 18 divided by 2 is 9. And here you can see my two x values, which we can call x-intercepts, we can call them roots, and we can call them zeros. Let's look at another example. 1. Okay, I'm going to start this example off by labeling my a, b, and c. So I can see my coefficient to my x squared is my a, so a equals 2. My coefficient to my x is my b, so my b equals 5. And then my constant, which is my value that doesn't have a variable, is my c. So in this case, my c is negative 12. All right, so I'm going to quickly substitute those values in so that I can solve this formula. So x equals negative b, so negative 5, plus or minus the square root of 5 squared minus 4 times my a value, which is 2, times c, which is negative 12. And all of that is going to be divided by 2 times my a value, which is 2. All right, so let's simplify this a little bit. So we've got negative 5 plus or minus, well, let's see, 5 squared is 25. And then I take negative 4 times 2 times negative 12. I'm going to treat that minus 4 as a negative 4. So negative 4 times 2 is negative 8. Negative 8 times 12 is going to give me a positive 96. And all of that's going to be divided by 2 times 2, which is 4. So let's simplify this just a little bit more. So we have negative 5 plus or minus the square root. So 25 plus 96 is 121 divided by 4. So we continue to simplify. So x equals negative 5 plus or minus the square root of 121 is 11 divided by 4. So this is where I'm going to break it into two separate problems. So x equals negative 5 minus 11 divided by 4, and x equals negative 5 plus 11 divided by 4. So let's see, negative 5 minus 11 is negative 16. Negative 16 divided by 4 is going to give me a negative 4. Over here on the right, negative 4 plus 11 is going to give me 6 divided by 4. That does not divide out evenly, but I can reduce that fraction to 3 over 2. So my roots, or my zeros, or my x-intercepts are going to be negative 4 and then 3 over 2. One more example to look at. Okay, I'm going to start this problem just as I started the others, and that's by labeling my a, b, and c. My a is the coefficient to the x squared, so in this case it's 3. You'll notice that there is not a b or c value in the equation, so I'm going to say b equals 0 and c equals 0. Since there are no b or c values in the equation, we just substitute in zeros for those values. So I go back to my formula, and I say x equals negative b. Well, b is 0, and there's no such thing as a negative 0. So I'm going to put 0 plus or minus the square root of 0 squared minus 4 times 3 times 0 divided by 2 times a, which is 3. So again, I just substituted in the a, b, and c into the formula at the top. Now I'm going to simplify. Well, I have 0 plus or minus the square root. 0 squared is 0. And then we have negative 4 times 3 is negative 12. Negative 12 times 0 is 0. Divided by 2 times 3, which is 6. We continue to simplify this. So we have 0 plus or minus 0 divided by 6. So I'm really left with one answer, 0 over 6. And 0 divided by any number just equals 0. So I only have one root or one 0 or one x-intercept for this particular problem, and that is x equals 0.